Hello. All right. Hi. Sorry. Set another meeting, and I'm here now. Let's go. No music today. Sorry. Austin, go ahead.
Hey, Professor. I had a question about remove last from the old Arraylist that just dealt with integers and not generics.
Yeah.
So I get why it's like super important to remove, like, and set it to null for generics because we're storing all that information. But for ints, we said it like it's not so necessary.
Right.
But I was kind of wondering, like, doesn't that give the user access to kind of like get from that index and like see information that they really shouldn't because we kind of want to like delete it?
Yeah, so arguably you could say you shouldn't be able to do that. Really, the thing you should do if someone calls get is, like, say you write in a 0. Then, yeah, it's true that in the future if someone does get, then they now get that 0 instead. But the correct behavior, in my opinion, is that actually an exception should be thrown. It's just something we haven't covered. But yeah, it's a fair point. Like, this is secret information still laying around. But I don't know that a 0 is better.
Okay, thanks.
Yeah.
And I said one more question.
Yeah.
So what's kind of the convention for naming? Because like in past classes, they kind of said like capitals are just for like final like constants, and here we use it sometimes for lists. So is there kind of like a
Right. So I kind of break convention just a little bit in lecture and use the capital L for a list sometimes, specifically just because lowercase l is like kind of in typical fonts is a little ugly. I could have used like X or A, but yeah, I think using L for a list is a purely didactic thing and not something you would do in real code. Yeah.
Gotcha.
But I bet people wouldn't hate it if you did it. Yeah. It's more just a quirk of English orthography.
Thanks.
You got it. All right, Mishan.
Yeah, so in lecture 7, slide 30,
Yeah.
You mentioned how an S-list insertion is constant time, and I get how it's constant for add first, but wouldn't you need a D-list to make it constant for add last?
Yeah, let me look at slide 30. You're correct. And so let me see what the wording is I have on the slide. Yes, so that was assuming that we're doing an add first. Okay, fair point.
Oh,
yeah.
Okay.
Yeah, so let me share this real quick, just in case anybody has no idea what we're talking about, which is likely. Okay, oh, weekly surveys. Okay, I'll show that in a second. All right, here we go. So this right here, yeah, this it was noted that if this was add last, it shouldn't look like this on an S list, because an S list requires you go to the end of the list. So these were fronts. So thank you. I will make that change for future semesters.
I see. And then, like, since it is a constant time, why is it a line? Like, I get that the integral of a constant is a line, but like, what's the correlation between that?
Right. So this is the total time to complete 100,000 inserts. So if I said, hey, insert 100,000 things, it takes 0.0001 seconds. If I only asked for 10,000 inserts, it would take, a tenth of that. So this is it's exactly what you said. It's the total time to complete all of the insertions.
I see.
Right.
So
and so what we're trying to do, sorry to interrupt, was like explain if we run like an experiment, what would we see? Yeah, and I think if I'm not mistaken, did we actually run a tiny experiment in the middle of this lecture? I can't remember. Sorry.
I don't remember, but
okay, yeah, I haven't taught it in 2 years, so I forgot.
Like, so you said constant time. So constant time doesn't mean that like regardless of how big it is, it's always like it's always at 0.0001.
It means that a single insert takes a constant amount of time. So in this case, we could do the math. Each insert takes, so assuming that thing on the y-axis is seconds, each insert takes that many seconds.
Oh, I see.
Make sense?
Yeah, that makes sense.
All right,
okay.
Cool.
Got it, thanks.
Yep. Classic point of confusion in this class, though. Bryant.
I had 2 questions. For the memory boxes, you said that 203 were created and filled. Would we also need a memory box for the pointer?
Which one? When I do which?
When you add 101 and 102 items.
Right. Okay. Let's see. 100, 101. Okay, that's an interesting point. Because we need the one for the A itself. Interesting. Oh, it's this is how I got around it. It's array memory boxes.
All right, so no.
I'm only
addresses
talking about
then.
the ones in the box itself. But yeah, if you count the actual pointer, then you have 2 additional ones for the temporary A's.
All right. I just don't want to be stuck between like 203 and 205 on an exam or something.
Right. Yeah. Cool.
Second question, is there a difference between slash asterisk and slash slash for a comment, or are they just both?
Slash slash. Do I do slash slash sometimes?
Mm,
You mean slash star star or slash star?
A double slash versus a slash star.
Oh, right. Like this right here. Versus
If you're typing,
these
I
two?
am unable to see.
Oh, you can't see. Sorry. These two here.
Yes.
There is no semantic distinction. It's just that this one, the end of the comment is the end of the line. And this can be multi-line.
So we wouldn't violate the style guide if we.
If you do a
use
line
double-
comment like this,
Yeah.
I don't remember what the style guide asked. I suspect that actually wants you to use these style, just because it's a little more standard. But yeah, these are fine too. I mean, just basically every different organization out there has different rules for comments. So if you go look at the like Princeton textbook, which we'll use later this semester, they use line comments all over the place, but we don't use them so much. But yeah.
Thanks.
Yeah, you got it. All right, Rhea. Or Rhea, sorry.
Hi, yeah, it's Raya. I had a question about arrays for the project,
Mhm.
and I guess it was just like it said that circular arrays might be better for us to consider implementing, but I was wondering why that might be the case because it seems a little complicated to implement like resizing.
Yeah, you're absolutely right. It is more complicated than not doing a circular array. However, it is much easier to handle add first and add last if you do some kind of circular approach. So let me open up a text editor real quick. So let's say, let me close this window. Hold on. Sorry, I had to close a bunch of windows. Okay, let's say we did not do it in a circular fashion and we had an array that was like 1, 2, 3, 4, 0, 0, 0, 0. So let's say we have a list which is 1, 2, 3, 4, and we're doing an array-based list where we have like private int x, and then we do it, like this is what x is equal to. Would be the code, right? Okay, so if we do something like this, if you don't do circular, the trouble you run into, which I'll ask you now, is what if someone does, let's do a public a list, or let's do array deck. If you had a class that looked like that, right? This isn't really code. This is just like a state that the thing is in. What if x is do suppose x is good. All right. So if you have that, then if someone calls L equals new array deck, or D equals new array deck, and then they do D dot add first, let's say 50. What would you do? Like, how would you modify this array? So what do you think? What might you do?
Yeah, so my original thought was without the circular was just to make a new array and put in the new value into the first box and then copy over the original deck.
So why will this run you into trouble?
I guess later you. Oh, do you have like wasted space at the end?
Well, it's not the wasted space actually so much. It's something else. So what's the time it takes to create this new array and copy everything? Like, is it constant or does it vary with the number of items?
I guess it varies.
Then so explain why. I mean, obviously I kind of led you there, but like in your set words, like issue runtime for add first varies with array size. Why?
Because you need to re-put all the numbers in.
Right. So that just ends up being slow. It's like, just as a comparison, imagine that you're, working at a or like you own a shop, and every time somebody buys something, you then have to like write down how much they paid and then rewrite down everything everybody else has ever paid in that same day. It would take forever. Like, you know, the beginning of the day would be no big deal. First person walks into the store, they buy something, you sell it to them, you write down $3. Next person buys something for $9, you write 3 or 9, 3. The next person pays 50 and you write 50, 9, 3. And then over time, you know, it's just gonna, like, by the end of the day, every write is gonna take forever because you're gonna recopy everything that's ever been done. So it's exactly the same concept here. Does it make sense?
Okay, yeah. My other question with circular arrays is like, I was thinking about if you just kept calling add first onto circular arrays,
Mm-hmm.
and then eventually you just get back to like you might just get back to where your last number was. And in
Right.
that case, I was wondering about how to handle resizing then.
Right. So this is the hard part of the, like, I would say that this challenge you've just described, which is basically, you know, let's say we have an array like so, and we do add first. So then it becomes 0, 0, 6, 1, 2, 3, 4, 5, 0, 0. So add first 6, add first 7, add first 8. I know this is tedious, but I personally, when I'm watching something like this, I find it so helpful to see someone actually do the whole thing out. So 9, add first 10, state of the array. I'm not showing all of the data because you have to have some kind of like pointers to know where the ends and the beginnings are. But eventually, you know, you get to the point where when you call add first 11, like you need to do a resize. And this is a design challenge. In the same way that, so figuring out how to do resize here is about is like, you know, kind of like tilt from Project Zero. It requires some different ideas, sketching, and experiments. So how would you do it? I'm just going to leave it to you to think about for now, especially since this isn't due until after the midterm. But yeah, it's quite challenging.
Okay, yeah, thank you.
Cool. But you've identified exactly, like, this is, I think, the one part of the project that is really pretty hard. And, you know, the other parts are challenging in different ways, but this is the one where you're kind of like adrift. And yeah, I'll leave it for later. So if you're stuck, or like, I encourage you guys to sketch things out and discuss with each other and come up with ideas. And if you remain really, really stuck, you know, drop by office hours or ask again here later. But yeah, I don't really want to spoil it. All right, Kim?
Hi, Professor. I had a question about one of the exercises in the lecture guide for I think the previous lecture.
Right. Oh, one thing I just remembered, sorry, someone asked, how do we do the surveys? So there's weekly surveys on the calendar right here. So make sure in the weekly announcements, like everything that's due is here. And so I don't know if you missed that first one, but there's 4, you get to drop 4, so no big deal. But that survey is right here, and those are every week. And just a reminder that anything that's due is always going to be at the bottom of the announcements. Okay, sorry. So your question was in one of the check-in exercises for which lecture?
The lecture number 6, lists and arrays.
Yeah. Okay.
And it's at the bottom. It's number 1 for the A-level exercise.
Oh, I see. Sorry, the study guide exercises. Okay. Okay.
I can put the solutions in the chat, but
okay.
I just had a question about
problem 10 from practice midterm 1 and Kartik's little book. Yeah, Kartik writes, he's a former TA and he writes really weird questions. So let's see what's, I had him in charge of study guides for a while. So we'll see if it's a question that I like. I love a lot of his questions, but some of them are very like out there.
Oh wait, sorry. I think it was the one about.
Oh, sorry, I clicked the long lecture. Lecture 6, you said, right?
Yes, it's number 10. Oh yeah, so it's number 10 on the PDF.
Oh, I see. It linked to the wrong spot in the PDF. Right. Okay.
Yes.
Got it. Okay. Arrays. Okay. Number 10. Okay.
Yeah. So I had a question about let's see, the last part, subpart C. So in the solutions,
I've literally never seen this problem, so we'll see how helpful I can be out of nowhere. But in the solutions, go ahead. Maybe I can maybe try, and if it's deep enough, we can all dig in together. Go ahead.
Yeah. So I also linked the solutions in the chat just in case you want to look at it. But I just had a question about like the ordering. So we get these 3 helper methods, and I was wondering if the ordering of sort by latitude and sort half long matters. Like if we could switch the ordering.
Let's see. Sort by whether you could switch 2 of these lines, you're saying?
Yeah, so I think so one of them sorts the rows themselves so that I think the lowest latitudes are at like the bottom rows. And then the other helper method sorts like within the row, like so that the columns I think are in increasing order. I was wondering if it matters like whether we sort the rows first versus sorting the columns themselves first.
Got it. This is a question that will require a lot of time because I'd have to first like learn what this problem is even asking. If you want to kick it to, I think this might be a better ed question just because if we try to digest it right now, it would take ages.
Yeah, I
that's my
can post it
inclination.
on it for sure.
Okay, sorry. Yeah, just because like I don't know that I want to take everybody on the wild ride into this question. Even looking at the solution, it's like very strange. Like this isn't typical. You know, it even involves like a little syntax feature we haven't done.
All right, cool. Yeah, I'll post it on Ed.
Okay, interesting.
Thank you.
This is a weird one. All right. Great. Okay, Kim. Wait, that's Kim, right? Sorry, Roy.
Hi, Professor. So I was looking at the project spec for ArrayDeck, and I tried to work through it. And I came across next first and next last. And I was just having like a conceptual questions like, so like once you initialize an empty.
You're looking about like at the slides I have?
Yeah.
Right, okay.
So like, why is it that next first and next last at the time of initialization they're different? Because I guess like my logic from a linked list deck is that next first and next last when there's nothing inside should be exactly the same because once inside 0, there's only one place to add, like kind of. So I guess like what's the logic behind that?
You know, you don't have to do it that way. That's just the way I did it. So if you want to make it the same, I think you can make it work. It'll just change the code a little bit.
Okay. So there's not really like a, I guess, reason.
There's probably some interesting invariant that makes it nicer. Like, let's see, if we go here, get first would be next first -1 and next last. Let's say you're in this state. I suspect it ends up being slightly similar to do it, or simpler to do it this way. But try it the same. Like I agree that from like a mathematical perspective, like it seems like for symmetry reasons, shouldn't they be the same? And maybe that solution's nicer. I don't know. Yeah.
Cool.
Yeah.
That cleared it up a bit.
Yeah. Right. Yeah. Yeah. Cool. So I'll just say they don't even have to be. Sorry. Actually, no, I'm gonna touch it. That's an interesting question. All right, try it your way, and I'll be curious to know. Like, come back in a, lecture or two, and let me know if it worked out well. But I haven't tried it.
Cool.
Great, Judy.
Hi, Professor. Just for like the doubly linked list part, because I feel like I get how next works, but then I'm not too sure like how the previous one works, and like how would you add it to like an existing code like that already has next?
Let's see, hold on a sec. Add last, get last, remove last. Okay. Sorry, I just realized I had the old names for the methods from like 4 years ago. So the question is, how would you work with the previous pointers?
Yeah, kind of.
I mean, I think where I would start is whenever you create an empty list, like I think the most natural thing to do is to first make sure that when you create a new, let's see right here, when you create a new D list, like I would create a constructor that after you run the constructor, that assuming you're trying to do the circular thing, which is the way I would do it. Gotta find the right slide. I went way too far. Okay, this slide right here is to, oops, assuming I'm sharing the right thing. I am, okay. So this slide right here, I think, is the key slide that really is most important. So when you write your constructor for your linked list deck, I would make sure that when it's done, that it looks like this, that your object is size 0, that's a sentinel pointer that has a node class.
I don't think I'm seeing it if you type anything.
Yeah.
Okay,
there you go. Ha, right. Sorry. So you want a size which is 0, a sentinel pointer which points at a node class, and this node class should have a previous, an item, and a next class. One thing I would recommend against is taking the existing S-list code and trying to adapt it. I think that's a lot harder than just building it from scratch. So in other words, if you try to take, oops, wrong one. So if you try to take this S-list class here and you try to modify it in such a manner that it works, I think it's more confusing. I would really recommend starting from a blank file, because otherwise it's like you walk in a little bit, like you can look at these for reference, of course, but I find it like harder.
Yeah.
Yeah.
I think that's what I was like working with.
Right. So, rather than doing that, I think what I would do is say, okay, if this is the picture I wanted, how would I do that? Like that, and you can test it out in the visualizer by writing a main method that creates a empty linked list deck. And when you've done so, it should look, roughly like this. It'll have, I mean, it'll look different, but you have to like, but it should have you should have a node class that has 3 instance variables, previous, item, and next, and they should look like this. That's where I would start.
Okay.
Cool.
Got it.
Yeah.
Thank you.
You got it. And one thing I'll say is like, one of the reasons I suggest that is rather than just like working with the existing code and adapting it, is that I think you just understand it better if you're like, even if you're just retyping code that's somewhat similar, and just think about what you're really building. Yeah.
Yeah. Okay.
I hope that helps.
Yeah. Thank you.
All right, Daniel.
Right. I had a question about the casting of generics. So in the lecture, you mentioned that for some reason we have to use an object array when creating like the generic array. I was wondering if this has anything to do with like casting it with respect to like the new keyword. Like, is new kind of like treated as like a method here?
You can think of it, as a method that returns the address of a new object, right?
Right.
And so the type of it, there's a thing in Java where you're not allowed to create new arrays of a generic type.
And is there a particular reason for that?
Yes. When generics were introduced to Java in around 2005, they needed to maintain the ability for the Java 8, or wait, no, it was Java 6. I don't remember what Java it was. Maybe 6. That was the first one with generics. Maybe it was in 5. They needed the ability for the Java interpreter to be able to interpret old .class files. So if someone compiled the class file in Java 4, they needed it to work with the Java interpreter for Java 5. And to do that, they couldn't, I don't know exactly the details of this, but they couldn't make generics like a real feature of the language. So in .class files, which we haven't discussed in any detail, there are types and so forth in there, but one thing there are not is generics. So generics are actually entirely a construct in the Java language, but when it compiles to a class file, all that information about types is lost. So this is something known as type erasure. And it's a somewhat controversial facet of how the Java generic system works. And it leads to all kinds of very strange things that you can do. Like, for example, if you want, you can, when you create a new array list, let me go into IntelliJ, and let me share the right screen. So if I create an array list, for example, I'm kind of giving you more than you wanted to know, but if I create an array list or an A list, I can actually do this, even though A list is a generic type. And if you mouse over this, it'll say raw use a parameterized class A list. But for these historical reasons that have to do with maintaining binary compatibility, they, like, secretly in Java, whenever you're doing this, there is no A list of integers. There's actually an A list of objects, and there's a bunch of like secret casting and uncasting and stuff that goes on under the hood. And it's all just like syntactical convenience. But it turns out that you can technically do this. And then once you do this, you can start adding like, I don't know, 5 and horse and whatever else, and it'll just work. Yeah, so if you do that, then it's a little weird because when you get last, or let's say we do get 0, you know, I have to do object to retrieve objects because there's no known type. And so I know this is not what you asked, but it is related to what you asked. The fact that this is popular in Java, like this above is an example of the secret type erasure properties of Java, which you are not expected to ever know and should never know. That's what I would say.
So does this type erasure lead to like having like an array of like you have like add last 5 and add last horse,
right?
So those are 2 different types within.
Correct, but they're actually not 2 different types because they're both, as we'll talk about in lecture on Friday, they're both objects. So if I run this code, it won't crash. It'll work fine. And so if we do the visualizer, what ends up happening is, well, this is not an accurate picture because the way the visualizer works, but this right here is really a pointer to an object of type I integer with the value 5 and so forth. So yeah.
So then does, I guess, like 5, like we would usually think of this as an int, but like for some weird reason with like how generics work and how this I guess type erasure works, like 5 just gets converted, the int type.
Yeah, what it secretly is this. I don't know if it'll display in the visualizer, but let's find out. Okay, so there's a class in Java called I integer. Doesn't show it, bummer. But really what it is it's like a class which has an instance variable which is of type int. So this isn't really the number 5. This is actually, like, if I were to draw this thing,
it would be like another memory box within the object that stores the integer 5. Okay.
Yep. Yeah, I'm gonna draw it out though for future reference. See if I'm sharing this right screen. Okay, it's getting a little meta here. Hold on, I got my zoom controls on here. Okay, so let's see. This I would say is an inaccurate picture on the part of the visualizer. I would say what it actually should look like is what you just described verbally, which is this is really pointing to an object which has an instance variable which has the number 5 in it. That's what's going on here. Okay, so then back to your original question. Why can't we create generic arrays? So there's, I'm forgetting the last detail. So I led you down this path, but basically, one of the side effects of all this like sort of weird stuff is that they decided not to allow generic arrays to be created for this binary compatibility reason, like to make everything work with old code. Let me try and hunt this down actually. Okay, sorry.
So it's like kind of like because like you don't want to like, I guess, have like incompatibility with like previous versions of Java, you want to like I guess, like add on to the existing code, for lack of a better term. And so like you can treat generics as almost like a separate, like, I don't want to say like class or object, but like a separate like syntax for supporting other objects.
Sorry, say that again.
So like, can we think of generics as like a way of supporting other objects?
I would say generics are a way of trying to introduce type checking where no type checking was previously possible. So what it does for you, if I go back to this code here, if I now change this, like this is something that you really typically don't want to do in Java,
Right.
like have multiple types in one array list. So what you'll typically do is this, and then the compiler will start yelling at you and saying, sorry, you can't do that. That's what I think of generics. It's like a constraint that says, please don't let any old object in here, only let integers in.
Okay.
Yeah, even though secretly under the hood, it's all just objects anyway. There are no integer arrays. And one of the side effects of this, by the way, is that in Java, you can't really create an array list of integers. Like the underlying backing array is not a bunch of 32-bit memory boxes. Instead, it's a bunch of 64-bit memory boxes that point at objects containing 32-bit memory boxes that have numbers in them.
So it's like an array is like a series of like reference pointers you can think of.
Right, exactly. So the A list above is an array of 64-bit references that point at objects with 32-bit instance variables. For this reason, generic A lists are more memory hungry and are a little slower than an implementation of A list that uses only ints. So if you hard codes ints.
Okay.
There is a huge project underway called Project Valhalla to remedy this issue. They've been working on it for 5+ years, maybe in a few more. Yeah, so this is all stuff that is pain. If you're curious about this, I'll just throw out there for anybody. Take CS 164. Yeah.
And I guess then my last question is like, since we have like this A list that is an array of references, can we think of like linked list as like a kind of like a nested loop of references?
Say a nested what?
A nested like series of references. So like we have a reference to a linked list instance, which then has like another memory box that points to another reference.
Yeah. We wouldn't call it nested so much as a like a recursively linked one. Yeah. Sure. All right, cool. We went out into the stratosphere there. Sorry. Maybe we should have done that piece problem. Let's see. Okay, I'm looking at the chat. Funny. Okay, cool. Yeah, what's next? If nothing, we can go do that weird Kartik problem. Let's see if anybody else has anything else. Oh, right. What's the pros of using a linked list deck versus an array list deck? That's a really interesting question. And one of the big points of the class is thinking about these linked list-based structure versus array list. So maybe I'll turn it around on you folks. Let me open up the spec. I'm assuming everybody has looked at these, knows roughly what's going on. I mean, a deck is very similar to the list structure we had in class, just a little more general, but I'll open up the spec. Okay, so what are the advantages of a linked list deck over an array list deck? Anybody want to, here's all the methods of a deck. Anybody want to talk about an advantage that one may have over another? Feel free to chime in or raise a hand.
Constant random access.
Yeah, constant random access. So Git in a linked list deck, you have to actually scan through the deck to find it. With the array deck, you have to, it's very fast. You just get the item immediately. Yep, that sounds good. So that's the advantage, I'd say, of an array deck. And it's a big one. If you want to get an item from the middle of the deck, which, by the way, I should note that a real deck in the real world would not have a get method, but I included it for pedagogical purposes. I think really this should be called like random access deck, because it's a little strange that you can get the middle items. It's not a normal thing in a deck. Hey, what's an advantage of the linked list deck? This is a little more challenging. So yeah, you noted that linked list decks, they use exactly. You can make 61 B problems about that. Yeah, linked list deck problem. There's two things. One, you guys actually have them both. So one of them was linked list decks. Like in some sense, they're a little more memory efficient. It feels like, because they don't have all these extra array entries. But on the other hand, linked list decks are just a little heftier because they have these like previous and next pointers for every object. So I don't think you really get a memory savings with a linked list deck. The main thing is that linked list decks don't have to worry about resizing. So in some sense, one, the code is simpler, maybe. Like it's easier to get a working linked list deck implementation, as you'll see. So I think that's a reasonable argument, like if you're in a new environment. And there's one other thing about linked list decks, which is that if you have a really, this is like a sort of obscure advantage, but if you have a really big linked list deck and a really big array deck, the add first method in an array deck can occasionally have lag, right? So let's say you have like hundreds of millions of items stored in an array somehow, which you wouldn't usually, but the add method could actually take an observable amount of time, just that one add operation. Like if you get unlucky, you do add first, and that's the one that causes it to resize from 100 million to 200 million, then you have to wait for that array to get built. That's still not very long, right? But there are extremely small number of applications where the linked list deck might give you a slight speed advantage because you don't have to wait for all that. However, I should note that in the practical purposes, like if you look at real Java code, the array-based implementation of the list, which we'll get to either this Friday or in a week, like people tend to just use the array-based version by default because it's generally better. Now, this is not true later, though. We'll see advantages later where you really want where a linked list based implementation of something, it feels better. So yeah, but this duality between an array based data structure and a linked data structure where you have objects that actually have pointers to other, like this is a classic trade-off. And for a list, an array is the clearly better, or is the slightly better choice for almost all circumstances. Once you get over the challenge of having to deal with it's harder to implement the array-based version, but you get better performance overall, other than the resizing. Okay, yeah. You got it. Thanks for the good question. And we'll come back to that later. We talk about maps instead of lists, that kind of thing. All right, what's next? Thomas.
Hello, Professor. I had a question about the circular array list.
Yeah.
So since we don't have any sentinels, would the first and the thing storing the start and the end of it just be indexes? How would that work?
So in at least the implementation, like my rough guess as to how you might approach this problem. Let me find this slides again. Okay, hold on a sec. Slides. Okay. So you were saying, let me share this window. All right, this right here.
Yes.
We're talking about, yeah. So we don't have any kind of sentinel values, at least in the version I came up with. And so what was the question there?
Would the start and the end of the array list just be indexes?
Yeah, in my case, that's what I did, right? Like I indicate the start and the end. So this is the start, you mean, and this is the end?
Yeah.
Yeah. Yeah, I'm storing that information as these values. You could actually also, when you create the thing, create like L and R and use that information somehow. Though it's a little awkward because if you were to do that, let's see, if you try to do something like this, then it feels like your sentinel is going to get moved around a little bit. So I don't know. You could. It seems strange though. I'm not sure that's helpful at all to have basically like a sentinel letter or something. But there might be some way that this simplifies one's thinking about code. But my gut feeling is that creating some values that are always there, you're not really actually saving any special cases. But I can imagine that the code might end up being simpler maybe. Here's the thing that's weird about that though. If you did something like that, you still need to keep track of where L and R are, right? So if you did something like L location 3, R location 6, then you don't really need the L and the R, right? Like they're just like.
But if the start and the end move, then when we do a get, we also have to do like a calculation. We can't just get whatever index we want.
Yeah, you're right that if I store it like this is not the only way to approach the problem, by the way, but if we allow the data to float, so to speak, then yeah, if someone does get 0, I need to know where 0 is. Yeah. And like I'll reiterate the lesson of project 0, which is helper functions really help. Because what you want is when you're writing the add first method, or get, like when you write get, or write get last or whatever, you don't want to be thinking. You want some helper method that makes it kind of obvious what to do. So you really don't want is like in your get last method to be something like actual secret index equals like a.size minus get first plus whatever, like divided by 2 or whatever, whatever it might end up being. Like there should be some kind of, I just made this up by the way, this is not right, like it doesn't make any sense, or sorry, but you want to write helper methods to make it obvious how to get the ith item.
All right, thank you.
You got it. All right, let's see. Oh, that was Thomas. Yeah, get secret index is exactly what you want to do, something like that. All right, what's next?
Can you go over again why we can't have like the first and last, like next first and next last, like values be like in the beginning of array deck? Why do they have to be in the middle?
Oh, they don't have to be. Yeah, for me, it was easier for me to explain what's going on to start them at 4 and 5. You could start them at say 0 and 1 and still have the same basic idea. The trouble with that is that if you do add first, you immediately wrap around and have to think about that. So it's like harder to experiment if you start at 0 and 1. If you start at 4 and 5, then you can kind of like do a little exploratory coding and get something that kind of works immediately, right? Someone else noted earlier, like there's no reason they need to be 4 and 5. You could do 4 and 4, or you could do 0 and 0, right? Like maybe that's the most natural approach, is to have them both be 0. It's just a matter of making all your other code work if that's the case. But for me, at least, it was most natural to start in the middle, because then I had to be thinking about the circular nature immediately, and it also let me like kind of hack together something that halfway worked before I got something that really worked. Does it make sense? Maybe. I guess the short answer is if you start at 0, then if you do add first, this immediately needs to wrap around, and that's probably a little harder to do when you first start. But of course, it can work anyhow. Any next first, next last you want can work. Next. maybe I have a question for you then. I guess everybody hasn't done this yet, or no, nobody's done it yet. Never mind. Okay, I don't have any questions. I'm gonna ask what you thought of lab 3, but probably none of you or few of you have done it yet. So I'll wait. Other questions? We can go philosophical. You can even leave 61B behind if you want. We only have a few minutes left anyway.
I have a question. Where did you learn how to teach?
Just doing it, I guess. Let me think. Where did I first teach?
Did you have any like formal education in
No.
education?
No, and I still don't, honestly. Like I kind of know. My first teaching ever, I did a tutoring job at UT Austin because they pay $10 an hour. That seemed pretty good in the year 1999. Yeah, it's fun. But honestly, I didn't really discover teaching until I got pretty deep in grad school. Let me look myself up on HCAN. So you look at my really old ratings. The first time I taught, I'm gonna go way early. Yeah, so I did let's see if I share the screen. So as a grad student at Berkeley, the first time I taught EE40, I didn't do a very good job. I'm gonna do 2.7 out of 5, which is pretty bad. Yeah, because I was trying to wing it, because that's my nature. So then I learned that semester you can't just wing it when you're teaching. Where I guess I learned to teach was probably this class right here. I mean, I did pretty well teaching these ones, but I decided like teaching was really interesting and fun, and I experienced a lot of like social anxiety around disappointing people. So in this class, where I was in charge of the class, like I was the instructor. Oh, it's not that one. Sorry, it's some EE40. Here we go. Where's my summer EE40? This one. That's not right. Summer 2005. No. Wait, where's my main class? The one that launched my entire career. What the heck? Oh, this one, summer 2010. Yeah. So this class right here, I was like responsible to not screw up, and I had all eyes on me. And I guess I was forged in the crucible of that experience. Yeah. I think part of it, I don't know. I don't know where I learned. I just did a lot. But yeah, my training wasn't really that good, honestly. And for that reason, I'm terrified of teaching a teaching training class because I don't really know how to teach how to teach. I give tips to my TAs, but yeah. Anyway, I don't know if it's a useful answer at all. But jumping in and trying.
Mm-hmm.
I don't even know what this is. That's not a thing I taught. What is 197? Anyway.
I have a question. Do you still have the hat you wore sideways in the video?
Probably. I don't remember what it was. What was it a hat of?
Oh, I don't know. It's just white with tags on it.
Yeah. I'll try and find it. It might be here. I'm not a big fan of having stuff, so it likely got purged. But yeah.
Also like this poster of some band.
Oh yeah, Travel Fox is what we called it. They're actually called like the Little Tigers, but it was like an ad for a brand of clothing called Travel Fox. Yeah, I love that. I still have that. Yeah. 4.5 out of 4.8 at a rate my friend. I haven't looked myself up on Rate My Professor in ages. Let's check it out. See if I have anything cool to say or mean. Oh no.
Oh no.
I'm getting wrecked. Cool. I was doing good till last year. Oh wait, I'm only
really 4.8 out of 5 is really good.
Yeah, all right. Few partial credit graded mainly by exams. Okay. I'm hard to reach. You're wrong. I did a live Q&A every Monday, Wednesday, Friday for 3 hours. 3 hours a week. And only 10 people came. Huh?
Yeah.
Anyway, I don't know. Not sure what that means. All right. Well, there you go.
All right,
interesting.
Well, thank you, Professor.
All right. I mean, it was inevitable that I would get wrecked for, being too hard. It took until fall. Interesting. Okay, cool. That's the most helpful review. All righty. Anyway, fun. Cool. Talk to you guys later.
Mhm.